Okay, part D. The student builds a different circuit. Figure 3 shows the circuit. And the circuit's here. Explain how the readings on both meters change when the environmental conditions change. And it's worth 6 marks. So 1, 2, 3, 4, 5, 6 bullet points. Right, let's have a look. So explain, remember, means describe what happens and then say why. So the 2 meters I've got here, I've got current, so the ammeter, and here I've got PD in the voltmeter. And here I've got a resistor with a window, the circle means a window, and light coming in. So that is an LDR, a light dependent resistor. And what happens with a light dependent resistor is as light increases, so this is dark and this is bright, what happens is the resistance will decrease as it gets brighter. As it gets brighter, absorbs energy, the resistance will decrease. Okay, so normally as things absorb energy, the resistance increases, but for an LDR it's slightly different. So let's say first of all, when it's dark, and we're just going to describe what happens. So when dark, resistance of LDR is high. Okay, so when it's dark, resistance of LDR is high. That's a fixed resistor there. So overall resistance of circuit is high. Okay, so because that, what's going to happen? So here it's high, therefore the current is low. Through ammeter. Okay, and what's going to happen there? Current is low through ammeter, and if we can imagine what's going to happen then is because the resistance this is high, the potential difference, the energy lost as the current goes through it will be much higher as well. And resistance, and PD cross LDR will be high. Okay, so that'll be high. As light gets brighter, LDR resistance decreases. Because its resistance decreases, it'd be much easier for the current to pass around the circuit. So it's not going to, it'll come racing through here, it won't lose as much energy as it goes through that LDR. LDR resistance decreases, and so does resistance of circuit. So the whole resistance, the whole thing, the whole resistance decreases. This means current increases. Through ammeter. I randomly got a double T there, sorry, earlier. through ammeter and the resistors. Let's talk about what happens in the LDR. So current increases through ammeter and resistors. The potential difference across LDR decreases. Because it's easier to get through. So due to lower resistance. Okay, now the interesting one here is that what that's going to mean is the resistance, because the potential difference of the cell has to be shared across here and here. If this one goes down because it's easy to get through, the potential difference across this resistor will increase. Because it has to be shared across those two resistors. And now that first resistor is relatively much harder to get through. Than the LDR. So one of the things it might be, one of the things sometimes it's easy to do with these sorts of circuits is draw out the two different versions. And you can draw it out as sort of two fixed resistors. So I'm just going to replace the LDR with a fixed resistor, and this is dark. So during the dark, let's say that this is 1 ohm, and let's say during the dark this is very high, this becomes 2 ohms. And if this is 9 volts there, say I'm just putting some numbers on here, 3 volts in total will be 9 volts across here. Well, this will be 3 volts and this would be 6 volts, okay, in total. And if you wanted to work out the current here, you could as well. You could say, right, well, I know that V is equal to IR, which means I is equal to V divided by R. So potential difference will be 3 amps. So it's 3 amps in total there when it's dark. Okay, so then if I do the same thing and say, right, now it's the light. Oops. And I now draw it so that it's the same as the other one, 1 ohm. And let's actually say this has become so low, it's 0 ohms. Just to make my maths really easy for me. I now know that 9 volts there, well, it's not be anything shared across there at all, because V equals IR. In that case, potential difference there will be 0. So 0 volts, which means that's got to be 9 volts. And if I've only got here, I've got 1 ohm there. This will be a total of 9 amps. Okay, much higher. So the current's gone up. The potential difference across here has gone up. Potential difference here has gone down. Okay, that's how you might go about answering this question. It's just draw 2 circuits. So replace that circuit there with 2 circuits, one for the light and one for the dark, and give yourself nice easy numbers, okay, to help make it more straightforward.